A bug report that gets ignored is not a QA success. Finding the bug and writing it down is only half the job. The other half is communicating it in a way that gets it understood and fixed. That means clear and complete reproduction steps. A precise description of the actual behavior you observed versus the expected behavior from the requirements. The right level of technical detail for the audience who will read it, whether that is a developer, a product manager, or a support engineer. And enough context for whoever picks it up to understand why it matters and how urgent it is. Writing that kind of report consistently, across a full day of testing, when you are context switching between features and tracking multiple issues at once, is genuinely hard to do well every time. AI tools can help with this, and in this episode we are going to show you exactly how. We will cover how to use large language models to turn rough notes into professional bug reports, how to use AI to assist with root cause analysis when a bug is complex and hard to isolate, and how to build a repeatable workflow that produces better quality reports in significantly less time. This is not about cutting corners or producing lower quality work. It is about spending your energy on finding bugs and capturing accurate observations, rather than on formatting and structuring the written report. Let's get into it. The core use case here is simple and immediately practical. When you find a bug, you have a rough set of observations in your head. The steps you took to trigger the issue. What you saw on screen or in the response. What you expected to see based on the requirements or the previous behavior of the system. The environment you were in, the user account you were using, the test data involved. Translating all of those rough observations into a structured, professional bug report with all the required fields takes time and mental energy, especially when you are doing it repeatedly across a long testing session. A large language model can do that translation in seconds. You describe what happened in plain language, the same way you would tell a colleague about the issue in a quick chat message, and the model structures it into a complete bug report with a clear title, reproduction steps, actual versus expected behavior, environment details, and suggested severity. You review it, correct anything that is wrong or incomplete, add the technical specifics the model could not have known, and submit. The quality of the structured output is usually better than what most engineers produce when they are under time pressure and moving fast through a testing session. The second use case in this episode is root cause analysis. When a bug involves multiple interacting components and the cause is not immediately obvious, an AI tool can help you reason through the possible explanations systematically rather than starting from scratch. For bug report generation, the prompt you give the model matters. The more structured your input, the more useful the output. Include 4 things in your prompt. First, the context. What feature or user workflow were you testing? What environment, what user role or account type, what build or version if relevant? Second, the steps. Exactly what you did, in order, including the specific test data you used. The more precise the better. The model cannot know the specifics of your test data, so you need to provide them. Third, the observation. What actually happened? Be specific and concrete. Quote error messages exactly. Describe the UI state you saw. Note what data appeared in the response or in the database. Fourth, the expectation. What should have happened based on the requirements, the design, or the previous behavior of the system? Give the model those 4 things and ask it to generate a bug report in your team's standard format. If your team has a template, paste it in and tell the model to fill it out. For root cause analysis, the prompt structure is different. You describe the symptom in detail, list the system components you believe are involved, share any error messages or log snippets you have access to, and note what you have already ruled out or investigated. Then ask the model to generate a prioritized list of hypotheses for what is causing the issue, and for each hypothesis, what specific evidence would confirm or rule it out. This gives you an investigation plan rather than a blank screen. Here is a real example of the bug report workflow so you can see what it looks like from start to finish. You are testing a checkout flow and you discover that the order confirmation email is not being sent when a user completes a purchase using a specific gift card code format. You open an AI tool and type something like this: I was testing the checkout flow logged in as a premium account user. I added 3 items to the cart totaling $42. I applied a legacy gift card code in the format GC Legacy 12345. Checkout completed successfully. I received the order confirmation page showing order number 10045. The order appears correctly in the admin dashboard with status confirmed. However, no confirmation email was received by the account's email address. I waited 10 minutes and checked spam. Expected, confirmation email should be sent within 2 minutes of a successful checkout for all payment types. You ask the model to generate a bug report with a title, reproduction steps, actual versus expected behavior, severity, and priority. The output includes a clear and specific title, order confirmation email not sent when checkout is completed with legacy gift card code. It includes numbered reproduction steps, a clear actual versus expected section, and a suggested severity of high with a rationale based on the customer-facing impact. You review it, add the exact gift card code format you tested, verify the reproduction steps are accurate, add the environment details, and submit. Total time, about 90 seconds, compared to 6 to 8 minutes writing it from scratch. 2 advanced applications of AI in bug reporting that most QA engineers have not explored yet. The first is using AI to identify patterns across multiple bug reports. When you have a collection of recent bugs filed against the same feature area, say the payment flow or the user authentication system, you can paste a summary of those bugs into a language model and ask it to identify common themes, likely root causes, and systemic risks that the individual bugs might be pointing toward. This kind of meta-analysis is valuable but time-consuming to do manually, and it often gets skipped because there is always more testing to do. A language model can do a meaningful first pass in under a minute. The output is not always correct, but it frequently surfaces connections and patterns that are worth investigating, and that you might not have noticed looking at the bugs one by one in a ticket queue. The second application is improving the quality of existing bug reports in your backlog. If you have a backlog of poorly written bugs with missing reproduction steps, vague descriptions, or no expected behavior documented, you can use a language model to rewrite them into a more useful format. Paste in the existing bug report, provide whatever additional context you have, and ask the model to produce a cleaner version. Then review and fill in the gaps the model could not fill. This is especially useful when preparing a backlog for grooming or handing off a project to a new team. Bug reporting is a craft that matters more than most engineers give it credit for. A well-written bug report gets fixed faster, gets prioritized correctly relative to other work, and builds your reputation as a QA engineer who communicates clearly and professionally. A poorly written bug report creates confusion, causes back and forth with developers, and sometimes gets closed as cannot reproduce even when the issue is real. AI tools do not replace the craft of bug reporting. They handle the formatting and structuring so you can focus on the parts that only you can do, which are the accuracy of the observations, the precision of the reproduction steps, and the judgment about severity and impact. The workflow is straightforward once you have it. When you find a bug, capture your raw observations immediately while the details are fresh. Then give those observations to the model with the format you need, review the output, add the specifics the model could not have known, and submit. Over time you get faster at this and the quality becomes more consistent than writing from scratch every time. In the next episode, we are going to tackle a challenge that is becoming increasingly common on modern software teams: testing code that was written by AI. When Copilot generates a function and a developer commits it, what does your test strategy look like? How do you find the gaps that AI-generated code is most prone to? We will cover that in full next time. Subscribe so you do not miss it.